Welcome to Pre-Calculus Notes for Essential Skill C3, Log Rules and Equations. The first thing I want you to do is take a look at these and see how many you remember. So here's what they are. First, the product expansion rule. The log of a product goes to the sum of the logs. Second, the log of a quotient goes to the difference of logs. Next, the exponent rule. The exponent can be moved in front of a log. Next, a special case of the exponent rule, when the base of the log matches the base of the exponential expression. Recall that log and exponential functions are inverses of each other, and that means that they will undo each other. This should remind you of skill set A7. A function composed of its inverse function will result in x, as long as both the function and its inverse are 1 to 1, which these are. Same thing here. You've already seen the 1 to 1 property in skill set C1. And these are also inverse properties. We're just using a base of e. And then finally, the change of base formula, which you may or may not have seen. We'll go through it in more detail in a moment. For now, just make sure you have it down. Log base k of a over log base k of b. These log rules are somewhat abstract, so we're going to start by doing some examples where we make it very concrete. We have a difference in logs. That's going to be our quotient rule. When we have a difference of logs with the same base, that's the same as the log of the quotient. In example B, note that this is not a difference of logs. This is log minus 2 log. We have this coefficient that we have to get rid of. Using the power rule, we can transfer that coefficient up into the input as an exponent. See if you can do the next two on your own. Here are my solutions. Notice we can't simplify this any further. We don't have a convenient base. Example 1c is very similar to what we're going to do in example 2. We're going to combine these into a single expression. First, we get the coefficients on top as exponents. Now it's a single log. Try part B. Here's my solution. Next, we'll look more carefully at the change of base. Keep an eye on the rule if you need to. In this case, 7 is A, 2 is B, and the base we're changing to is 7, so 7 is also K. Log base K of A over log base K of B. We can simplify this somewhat because log base 7 of 7 is 1. In the next example, we're translating to base E. Any log base E is going to be the natural logarithm. So here's what that looks like. This doesn't simplify. Try the next two. Here are my solutions. This doesn't simplify either. Also notice we don't use log base E here. This is log base 10 of E, the common log of E. Next, we're going to look at simplifying expressions using change of base to start. The first thing I'm going to do is pick a common base to change both of these logs into. I'm going to choose base E because natural logarithm is less to write. Next, I'm going to use the exponent rule to simplify some of these expressions. Conveniently, this means I can now cancel some of these logs. Log of 7 cancels with log of 7. Log of 2 cancels with log of 2. And we're left with negative 2/3. Try these three examples. Here are my solutions. You may have noticed that these logs are resolvable. I'm still going to use the log rule just to demonstrate it. With the common denominator, we can add, and then we'll resolve. Finally, we'll look at solving equations. The first thing you need to keep in mind is that the domain is restricted. We can only take the log of positive numbers. What we'll do is when we find a solution, we'll plug it back into the original equation and see if we're ever taking the log of a negative number or of 0. If so, then we'll disregard that solution as extraneous. When we solve these equations, we're going to use a combination of all of the log rules. Please feel free to pause at any time and work ahead. Practice is important. The key to example A is the inverse property. 12 to a power and log base 12 are inverse functions of each other. Inverse property again. Product rule. At this point, we have log equals a number. We switch to exponential form. Inverse rule again. These are both valid because they never cause you to take the log of a negative number. This negative 3 ends up as an exponent, so that will yield a positive number. Exponent rule. Product rule. When we have log equals log, we have the one-to-one rule. Please remember to pause and try these. Experience is very important. For example G, we'll use the product expansion rule again. Rule of inverses. We don't divide by x on both sides. Dividing by a variable quantity could have you dividing by 0, and we don't want that. So we'll subtract the x over to the other side. One-to-one rule. Example K presents us with a problem. We have a constant, a 3, along with log base 2 of x, and they're being added. We have no way of combining these. So our solution is to gather the logs on one side and then use log rules. One-to-one rule.